Welcome everyone. Thank you for joining our Java Meetup today. I am happy to introduce our two speakers who will share their knowledge with us. Our first speaker is Yaroslav Dmitriev, a senior Java developer, associate software architect, expert, and lead from Andersen. After Yaroslav, we'll hear from Juarez Alvarez Barbosa Jr., a senior principal Java developer evangelist from Oracle. Here's how our meetup will go. Yaroslav will give his presentation, then we'll have a Q&A session, then we will move to Juarez's talk, followed by another Q&A. Now, let's start with our first presentation. Yaroslav, please begin.
Okay, thank you. So let's share our presentation here and turn it on. Okay, it's on. So, hello, ladies and gentlemen. Today we are going to dive into the creepy world of the code documentation. As you all know, developers don't like to write docs, but at the same time, we all are happy when they magically appear, and we immediately become angry when someone shares us a library or API without a detailed documentation attached. Even I have been trapped in this circle for a long time. When I was an ordinary developer around 10 years ago, I thought that there is nothing more important than the code. I was taught to keep the code simple, clear, and testable. I was sure that it's enough. The life of a developer seems to be so simple. You shouldn't care about team management, architecture, scalability, reliability, and especially documentation. Only when I was able to pass several certifications, gain some vital experience as tech lead and software architect, the truth started to appear from the grim shadow of the reality. Today, we will together remove the curtain of darkness from this topic. This topic is mostly for junior and middle developers, as I suppose that seniors are good enough to support their projects with documentation without my advices. So it will be mostly like a fairy tale. We will have a look at the world of the documentation in general and then step closer to the part that developers don't like most of all, code documentation creation. Nowadays, we are surrounded by so many documents, white papers, standards, user guides, API documentation, etc., etc. Sometimes we can barely differentiate one from the other. So I suggest taking a small break here and refresh everything we know about project documentation in general. Project documentation can be divided into two big groups: process documentation and product documentation. The first one helps the team to answer the question how we build a product or a project, while the second one states what we are building. In order to create a solid code, we need both. Roadmaps allow us to predict releases and better understand what and when will be released. Standards are the best way, or standards, better to say, are the best way for developers to keep the same approach in writing the code. Disaster recovery plans allow us to negate panic and restore our environment, even if the whole infrastructure is down for a short period of time. Reports and metrics reflect how time and human resources were used during the development. And finally, training materials, they allow project manager and tech lead to onboard new team members much quicker without interruption of the development flow. The second big group of documents is called user documentation. As developers, we rarely pay attention to it, as it's mostly how-to documentation, how-to guides for end users and administrators. The most interesting group is in the middle. It is called system documentation, the description of what we build, the backbone of the documentation. Product requirements is the basement for all our user stories, epics, tests. It describes the system functionality and is used across all other documents in the list, especially architects documents. UI UX design documents describe how the systems look like from a user perspective. Software architects documentation, or mainly architecture vision document, is the detailed summary of what we are building with all the requirements, quality attributes, team composition, assumptions, concerns, deployment, and system architecture diagrams. Developers, QA specialists, and DevOps also have some dedicated documentation for themselves. Here, marked with a red dot, is our stop in this world of madness, the source documentation, or source code documentation. In order to help us better understand this topic, I have asked my old friends to assist me a bit. They are unusual friends, so be patient, please. So here is our support team for today. Skipper is experienced and purposeful architect. Private is young and naive junior developer. And Kowalski is well-trained QA specialist, while Rico is good, old, reliable DevOps. A few days ago, I was able to record how our team deals with problems with the help of well-written documentation, how critically they solve problems. So let's watch the recording.
Skipper, look. Analysis. It looks like a small incandescent bulb, designed to indicate something out of the ordinary, like a malfunction.
I find it pretty and somewhat hypnotic.
That too, sir. Right. Rico, manual.
Problemo solved.
And that's great, basically. As you could notice, most of the time, developers prefer to rely on their skills and experience rather than on a documentation. What's the reason of this? Firstly, we hate writing documentation. By default, we expect that we don't need it. I was able to find a few quotes on Reddit a few days ago answering the question above. Some people think that it's just a waste of time, like this. Personally, it doesn't change the behavior of my code. So why waste time writing documentation when I could be coding more? Documentation isn't difficult, and I do think it's beneficial, but it's not like it is going to make my unit tests pass better. Others think that they simply have no skills for it. I have no communication skills. That's why I hate writing documentation. Pretty nice excuses. What do you think? And of course, time. The lack of time is universal excuse. To be honest, guys, if you really think that time is the main reason, you need to pay much more attention to your time management. So how developers usually solve problems with documentation? My most experienced colleagues already know two simple tricks. If we don't have time or ability to write documentation, let's let the code speak for itself. Clean and self-explanatory code is the first powerful instrument. Most of us use high-level languages, which are pretty similar to normal languages. So why not to make code clear and understandable even for non-technical specialists? Sadly speaking, in most cases, it's barely not enough. The code is designed to be executed, not to explain what, why, and how. Also, what about examples? The problem is usually solved using the second instrument, unit tests, or just tests. They can give us an information about use cases, outcome examples, and describe the behavior of the code. However, the main purpose is to check if the code really does its job, not to explain with the plain English. Plus, also complex tests are extremely hard to read due to their size and certainly complexity. Yeah, DevOps just can mention about self-explanatory infrastructure as well. So it's no doubt that ideally we need some additional tools. If a project is big enough or it's a library or a framework, or the priority is to focus on the performance, the solution will be not to use single head of knowledge pattern, despite it's extremely popular on different projects. It's finally better to try some source documentation best practices. Let's see what our architects suggest us to use. So, if you are a responsible developer and you respect your teammates, their efforts and time, it's important to think about proper solutions of transferring the useful information, at least to a developer or on a developer level. Here are 3 source code documentation types that may help you. API documentation, Java doc. In some other languages, it may be called like doc streams, for example, in Python, and comments. But generally, all 3 sources can be seen in different languages as in the same manner. But what is the difference? So firstly, the audience. Only the API documentation may sometimes be consumed by people without technical background, while the other 2 types will certainly be used by your colleagues, even yourself, after a certain period of time when you will forget something, for example. It's pretty common. Hence, you should bear in mind how you explain things, what words do you use for it. I suggest to keep closer to the plain English in all cases. Don't make things overcomplicated. That's all about simplicity. Leave Shakespeare's English to professionals. The last but not least, if you are brave enough to support source documentation on your project, don't forget that all your pretty Java compilers, check style plugins, etc., won't help you when you change the business logic or refactor the code. You should always recheck related documentation manually to keep it on the same page with your current code. Okay, we have completed the brief overview. Now it's time to taste some details. A simple comment to the code allows the user to use all the might of the English language to describe something complex and convoluted. Just follow 3 simple rules, and you will never face any problems with over-commented code. According to my personal experience, in 99% cases, really clean code doesn't require comments, especially in production. However, it's quite common and useful technique when you are in a crunch and produce lots of code in local environment. Just use proper tags as to do or no, and for God's sake, please don't leave comments if your code smells bad. Just rewrite it instead of leaving a comment. It's definitely a wrong way to do that. In order to better smell what is this bad way, I have prepared a few examples of bad comments. So a perfect illustration of what can happen when developers change something but don't care about comments. Such texts may remain in place for centuries, even if the code for which we dedicated the comment has gone away long ago. So this comment seems to be created more than 6 years ago, which should be fixed by tomorrow. So I guess tomorrow never happened. The second example is also from a good friend of mine. Here is what he was able to find in his sources. Such comments as excuses, jokes, etc. are useless as come. Please use other ways of communication to express your dissatisfaction, and don't give excuses, just give your tech lead or architect the result. Java docs. Enough of these child games. Now it's time for some serious business. Javadoc is a way to add additional description layer to your variables, methods, and classes on the top of excellent, clean code. There are two main reasons why we actually need such long documentation. The first one is the distance between the code with a good performance and a clear code. And the second, even a clear code doesn't bring enough context. Every developer that works with the code should be able to answer three simple questions just by looking at the code. What is the purpose of the code? How can I maintain and extend the code? And how can I test it? Thankfully, Java doc tool is able to generate documentation based on a special description, which we create on top of our source code. In general, the rules are simple. Use clear descriptive header, as this on the example. Use add parameters, add return, and add throws. Don't forget about useful add code, and of course, the full might of the HTML tags, which will allow you to highlight examples or links or whatever basically you want. Also, Java doc with special doclets will allow you to generate documentation in different formats, like HTML, JSON, XML, whatever you want. On the right, here you can see a perfect example from the string class and Javadoc of the substring function. Here you may see that developers used all the things that they need for the documentation. The perfect header, which describes this simple function name, parameters list, return type, and the description of the possible exception. Of course, as for bad comments, I have prepared an example of bad Java docs. Please don't go too far away with writing documentation and achieving good document coverage. I have seen projects where even the documentation for getters and setters was compulsory. This is ridiculous. Don't repeat such mistakes. If this code is obvious, you don't need to write documentation for that to achieve 100% coverage. If you really want to be treated as good developers, just follow simple rules. Try to not to create documents for self-documented code. Keep your English at least at a moderate level. And don't put any jokes in the documentation. Come on, it's a serious business. It's not Reddit or some public chat where you can leave some jokes for the public. On the other side, API documentation is a good example of 100% compulsory code coverage, document coverage for your code. Your Java services mostly communicate with other systems using the API. I think you all know how easy it is to read documentation, to read documentation and implement your solutions when you integrate with Stripe, Twilio, MailChimp, Google Maps API, and some other popular services. That's all because they don't simply provide Postman collections and links to Swagger. I know it's still better than nothing, but anyway, that's definitely not the stop where you should stand. If you really want to be treated as a good API consumer most of the time, start with yourself and try to make your API documentation closer to what we have just mentioned. So this example shows us a Stripe documentation. Typical section divided into 3 columns: the menu, the main description, and code examples. So for your public documentation, use this structure every single time, and every user who is familiar with this standard will clearly understand what you want to show him. Navigation, description, code examples. That's all that you expect from the API documentation, and what your users will expect from your documentation as well. Okay, now I think it's time for some virtual hands-on experience. Let's try to imagine that we have joined a new team that develops something called the City Manager. We were told to be responsible for one module called the Marketplace. Our honest protagonist assumes that such a perfectly described project has all the documentation in place, and the only thing that he will have to do is just write the code. Oh, you're going to create the best city manager in the world. And developer says, if you say so, I assume there should be software architect documentation, source code documentation, UI documentation, etc. Whoa. I would say failed assumption at this point is a common thing. So the project starts. Something that looks like documentation was provided, but what usually happens with its quality? What should we do when the documentation is not clear, or some parts are even not covered with documentation at all? Our team has prepared an example how they usually jump on a new project and experiment with the new API if they don't understand what is written in the documentation.
No, I still can't read.
Then we're going off book. Go! Too much!
I'm getting the hang of this, Skipper.
Good! We're coming for you, Private!
Okay, our team has shown a perfect example. After some meetings with PO, you have noticed that the project that you have promised to enter doesn't sound like a city manager with modern skyscrapers, parks, etc. Instead, some medieval code. Luckily, we're able to detect the module which is dedicated to us. And basically, by default, you have no idea what other modules do. You don't have documentation for them, so you don't care. Without documentation, that's not your responsibility. And even if you will need to jump to the next module, I think you will just read the code and try to create documentation from scratch. Well, after some meetings with product owners, some notes appeared in your notepad, and you got the idea of what is the marketplace that you have to implement. And by the end of the tough day, the implementation is ready. Isn't it great? Let's find out. So we have some class called marketplace and some function which allows us to get a resource using input A, B, and count. So names are pretty common, pretty short. So the code seems to be created in a fast mode, but a few questions appeared. First of all, what the fuck is this? What this code basically should do? What is the purpose of this method? What is A, B, and count? Why do we assign name and type to the result? What is race? What this code returns? It just returns some new resource. But what is the domain purpose of this object? So basically, we can just say that this code does some creepy thing without any connection with the real world. Let's try to clean this code a little bit, refactor it. Maybe it will look better and we will not require documentation at all. Well, basically, it seems a bit better at this point. I have added two blank lines just to separate variables from actual methods for you, certainly. For now, at least, method name is clear, and variables have clear names, but still details are not clearly seen. If I had here information about purpose, variables will become too long and almost unreadable. So if I would describe the resource to sell, like user will sell this resource in order to blah, 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 blah. And if I will add a proper name for this variable, it will also look like a variable from the Spring framework, I guess. And the name will go beyond the edge of the screen, certainly, which is also not so readable. So two questions still remain. What is the purpose of the function trade? And what does it return? What this new resource mean? So in this case, we have to add a Java doc here. Finally, here is a good public method, how a good public method should look like. Every single doc can be easily split into three parts. The header, which describes the purpose of the function, parameters section, which describes the payload and the purpose of the payload, and finally the return type. And also pay attention to add code, add parameters that we used in order to better highlight the results in the HTML document, which will be created by your Java doc tool. Okay, let's summarize what we have learned so far. If we have some functionality, an API or a class or a service, in our case, it's marketplace, what if we just need to leave a note? In this case, we should use a comment. If we need to answer a few questions like what is the purpose of the class or service, how can we extend it, how can we test it, the answer is create Java doc to describe the meaning of it. If you have an API, which is public API, you need API documentation, especially when some external users without technical background will use your service. And if you just need to describe an easy start with your code, put the information into the README file. Okay, summary, we're close enough. Let's summarize what we have just learned. The minimal amount of source code documentation by default includes comments to the code, Java docs or doc strings, and API documentation. We should not create documentation or leave comments if our code smells bad. It's better to start the process with the refactoring and after that, create tests. Only after that, our code is ready for documentation. So don't comment bad code, better rewrite it. Also, try to use plain English when you describe something complex. You don't want to add an additional complexity by using difficult or rarely used English words. Keep it simple. Also, you have to remember that the maintenance of documentation will cost you, definitely, because all the compilers, most of the validators or code style checkers will not warn you if your code changes will not be mirrored in the documentation. So you will always have to manually compare documentation and the code. That's also the reason of why we prefer to create documentation at the very end of the production flow, when functionality will not change or changes not so often. I have prepared a few recommended sources for you. If you want to start creating Java docs like true masters, I have a perfect starting point for you. This Oracle official's technical article has everything that you might need: examples, explanations, and references. On the right side, 2 YouTube channels that may describe you everything that I have just told you, but in a bit more detailed form. And if you feel yourself brave enough, these 2 books are the best that I was able to find. Well, a bit boring at first glance, 500 pages plus each, but on the other side, both contain only compulsory data. So I recommend you to start with technical communication, and after that, jump to the writing software documentation. Bearing these 2 books in your mind, you will be able to create extremely clean and well-written documentation basically on every single project. I suppose today's short lesson was quite useful for you. It's just a piece of cake, and I wish you all luck and have a nice weekend. If you have some questions, it's time to ask them in the chat.
Thank you, Yaroslav. Thank you so much for that informative presentation. It was really fun and informative, as I said before. So we have some time for questions from our audience. I see we have a few questions in the chat. Yaroslav, could you answer for them?
First of all, can you guide me where I can see the chat?
I can read it for you. So first question, is it a good idea to ask ChatGPT to write documentation for you?
How do you think this presentation was created? Yeah, to be honest, I have asked ChatGPT to create several pages, write some documentation for myself, but the result was pretty unexpected. Well, I would say that 30% of what ChatGPT creates for us, especially when you show the code to the ChatGPT, seems to be useful. But in most cases, ChatGPT just describes what happens within the code without giving the information about your domain model, its purpose, and so on and so forth. In order to create a proper documentation, you have also keep in context the purpose from other documents that I have just shared: architects documents, UI UX documents, product requirements. It's pretty difficult to upload all this information into ChatGPT memory in order for him to analyze and create a perfect description of what you have just written in Java. So the short answer is that you can use ChatGPT for that, but also after that you should manually check everything that was written, and I am 100% sure that 50, 60, even 80% of what ChatGPT created will be rewritten with your own hands manually.
Okay, thank you so much for your answer. So we have one more question from the chat. How to find a trade-off between writing documentation and writing code?
That's a tough question. And the answer is time management. When your managers or architects or tech leads or whoever will give you a task, define how much time will you spend on the implementation, always try to save some time at the end for the documentation step. So by default, when we are asked how much time do we need for the implementation, they may think about the investigation, implementation, sometimes about testing, unit testing, but we barely forget about documentation step. So if you will simply keep this step in mind, but don't share this to your manager, just say the implementation will, for the implementation, I will need like 10 hours, keeping in mind that original implementation will be 8 and 2 hours will be left for the Java docs. That would be enough. Just don't cry on every single corner that I will spend this for the documentation, because I'm 100% sure that your managers will say, okay, just drop it, write the code, test the code, and that would be enough. And if you're in a crunch, you can just leave some comments within the code, write proper tests, and keep the code as clean as possible. This is the minimal amount of actions that you might execute to keep the code documented, at least with a self-explanatory mode.
Okay, thank you. It was the last question. So we appreciate your insight, Yaroslav. Thank you for sharing your experience with us today. Now,
thank you too, Alec.
Now I am pleased to introduce our second speaker, Juarez Alvarez Barbosa Jr. from Oracle. Juarez, please start your presentation.
Thank you very much, Ali. Okay, let me share my screen. One sec. Perfect. All right. So, hi everyone. Today my talk is about how to revolutionize Java database app development with reactive streams and virtual threads. For those of you who don't know me, my name is Juarez Barbosa Jr. I work for Oracle as a senior principal Java developer evangelist. I have over 20 years of experience in software engineering and developer relations. And currently, I focus on Java technologies, but also a little bit of Python, cloud, DevOps, and IoT, and and so on. And I'm a frequent speaker at some technology conferences, okay? But without further ado, let's get started. Okay, so that's our agenda for today. We'll have a look at, the big picture of Java app development with the Oracle database. Then also align that with the Oracle JDBC and the current standards and Java versions. Okay. After that, I will just present a block diagram with more details about how you can access the Oracle database with JDBC and Java. And of course, then we'll focus on exploring JDBC in the scope of both synchronous and asynchronous communication. We'll have a look at virtual threads and the classic platform threads and compare that to virtual threads as well. I have a quite interesting demo here. It's a simple one, but it will make evident how good virtual threads are for your application. After that, I want to shift gears here and then present some of the libraries that we have that are related to the Reactive Streams specification. basically RSI, the Reactive Streams Ingestion library, and also R2DBC, Reactive Relational Database Connectivity. And if we have time, I will present, some of the workshops that Oracle offers, as free ones for developers, talk a little bit about Oracle Cloud and the Oracle's ACE program, which is a program for distinguished community members, right? So first, at the end of the day, when we consider Java application development with the Oracle database, you can see here all the famous logos, concerning the Java ecosystem, things like Java itself, but also Kotlin, Scala, Groove, all the JVM-based languages, the ones that compile to bytecode, right? But you can see some, servlet containers like Tomcat, app servers like WebSphere, JBoss, and so on. The famous library or libraries, or perhaps the de facto one like Hibernate for object relational mapping. You can see Spring, Struts, and of course, the reactive strings libraries as well, namely Project Reactor, Aqua Strings, RX Java, and so on, right? But when we consider connecting to the Oracle database, you can see this blue arrow here. We have Oracle JDBC and UCP, which is actually the Universal Connection Pool, a connection pool developed by Oracle, which is really optimized, not only concerning connections to the Oracle database, but it also supports, the integration of some open source databases as well. But at the end of the day, we have the Oracle database, and that's what we call the converged database, right? Because with the Oracle database, regardless of your data model, if we are talking about relational, spatial, NoSQL, OLAP, or even blockchain, the Oracle database supports something called blockchain tables, So if you want to leverage the characteristics of blockchain, like, traceability or a single source of truth and better security and so on, you don't have to stand up a full-fledged blockchain network, because Oracle has such blockchain tables, and that's easy for you to configure. But at the end of the day, the converged database then is that in case, regardless of the specific data format and model that you have to address per your requirements, you don't have to consider another engine or database management system and so on, because Oracle, delivers everything, So, and we know when we add other new components to your architecture, at the end of the day, as you have additional moving parts, you are adding complexity. So you can avoid that and just use the Oracle database. And the nice thing, the latest version of it, 23 AI, we also implemented support to vector data type and vector stores and so on. So 2024 is pretty much the year of AI and Gen AI, and we have that covered as well. Okay. So as I said, the big picture of it and this block diagram, an overview of the Oracle database access with Java. Okay. So from the left to the right-hand side, you can see Java business logic. That's usually the user Java code with JDBC, and we are talking basically about client code, and that can be a mobile application, that can be a web application, a standalone application, you decide, it doesn't matter, or a command line application. But we have plenty of options here considering the connection to the Oracle database. In terms of the JDBC driver, you can see this dashed red rectangle here, with JDBC Fee and JDBC Reactive extensions. Okay, so the JDBC driver out of the box, it offers, of course, the classes and interfaces and everything that are required to connect with the Oracle database. But there's an implementation of the Java Flow API and interface introducing Java SC9 as well as an implementation of reactive extensions. And you don't have to add an additional jar, that's actually patched along with the jar, the JDBC driver classes, interfaces, and so on. So we are talking about just a single jar, right? But beyond that, we also implement reactive streams by providing first R2DBC library, okay, which stands for Reactive Relational Database Connectivity. And it's also an interesting way of using reactive streams, because you can combine it with those libraries that I talked about, like Akka, RX Java, Project Reactor, and others, okay? And we also have a kind of Oracle specific library as well called RSI, Reactive Streams Ingestion Library, which is quite interesting, by the way, because the way it actually ingests data. If you have, applications that have massive amounts of data, like, I don't know, social media, IoT, and so on, you can use that one because it does not usually use the common SQL mechanisms of the database, but actually it internally it uses what is called a direct path insert. Okay, so it will batch, the data and then bypass the usual mechanism and then quickly insert, all the data and the entire batch, at once. All right. So at the end of the day, regardless if we are talking about sync or asynchronous blocking calls, right? We have that covered by Oracle as well. And the nice thing is that now with the advent of virtual threads, we can also consider, perhaps reverting to use blocking calls with JDBC, because the way that it uses the underlying hardware resources and the way that the threads are now orchestrated are different. Okay, I'm not saying that reactive streams are not a choice for you. They are, and that's why Oracle offers all the options for you. At the end of the day, I like reactive streams by the way, but reactive streams are a little bit difficult to debug, because when you delegate a call to a framework that is based on reactive streams, you never know which thread or which component is actually processing the call. And with virtual threads and the usual blocking calls that we have in Java, at the end of the day, even the debugging tools and all the tools that we have in Java, they are oriented towards using the Java threading models. So that's easier actually to learn, to debug, and possibly the code will be easier to understand and simpler as well. Okay. Other interesting features, we have something called database pipelining, that you can also implement a kind of file and forget approach to it. So you can connect and send several different calls and without blocking, and then continue to process or perform additional calls and so on. Okay, so we have all these libraries and options for you. And then in terms of implementing the latest Java versions, you can see Java 11, Java 17. We are about also to support and certify Java 21. Okay, JDBC standards, that's covered as well. You can see the versions here. GraalVM, that's nice because actually the Oracle JDBC driver has been instrumented to work with GraalVM out of the box. It's quite easy. I have a blog post related to that you can have a look later on Medium. Okay, I talked about reactive streams and the Java Flow API. Same thing with virtual threads. Our driver has been tested and instrumented to work with virtual threads even before having virtual threads as part of JDK 21. The GA release of it. But at the end of the day, data access, you can say, okay, I'm doing JDBC for years now, or I know how to do, my stuff concerning how to connect to databases. But it's important for you to understand these libraries, because data access is really crucial in terms of mission critical applications. And we know when you have a bottleneck at the integration or the data layer, that can propagate to other layers. And at the end of the day, it might be perceived by your end users as well. So it can, in terms of degradation, impact your entire system. So that's why I'm exploring all those options and presenting them here, okay? In terms of Oracle JDBC, I talked about that async and sync, okay? With virtual threads, as I said, we can now use, again, synchronous DB access with lightweight threads, okay? Standard JDBC plus virtual threads, right? And that's still blocking. You can still use the debugging tools, and things like JConsole and all the tools that we can use with synchronous code. Okay, libraries apart from JDBC, usually libraries, they have to be compatible with virtual threads, but we are seeing pretty much all the main libraries and frameworks implementing it, even servers like Tomcat and so on. Okay, and I cited that Oracle instrumented the JDBC driver to use virtual threads, right? Reactive streams and programming, that's another option. A synchronous database access with non-blocking network IO. Okay, I will present R2DBC and RSI here this evening, but I have a blog post also exploring what we call JDBC reactive extensions, the Flow API that is actually perhaps embedded, and that belongs, to the same driver artifact, right? And you can combine all those options with the libraries, the reactive ones like Reactor, RX Java, Vertex, Akka, and so on. Okay. Just a quick recap here to make sure that everyone is on the same page. You may remember platform threads, usually a JDBC call blocks for hundreds of milliseconds. It has a kind of one-to-one mapping to the underlying OS kernel thread, right? So, and that's somehow resource intensive, okay? Performance can degrade depending on the number of threads. My demo will show that, by the way. Some things related to the stack memory and the call stack per thread. Typically, scheduling is also a little bit expensive, and depending on the operating system as well. If you are talking about POSIX or Unix, Linux, so all the POSIX-based ones, we have preemptive scheduling, and usually, in terms of threads, we have the priorities, and the processes and the threads, they may respect what you set in terms of those priorities. But with time slicing in operating systems like Windows, at the end of the day, there's a kind of round-robin fashion dividing all the resources among the running processes. Perhaps the situation is not so, I would say, optimized. But at the end of the day, speaking of virtual threads, just several different JDK enhancement proposals here. But the last one that actually released virtual threads, JAP 444, with this goal of dramatically reducing the efforts to write, maintain, and observe high throughput concurrent applications. Also avoid mapping the threads to the underlying OS kernel threads. This mapping one-to-one now. There's a way actually to have this mapping, but on top of it, the virtual threads, you can create thousands of virtual threads. So at the end of the day, you can optimize the way that you will use the resources, and you can scale better, right? The nice thing, or perhaps the outstanding, thing or the highlight concerning virtual threads is that they delivered virtual threads, without actually creating something too complex or altering the traditional implementation of threads and the threading model in Java. It does not alter the basic concurrency model of Java, just some additions to the Java lang thread, in terms of adding methods and some builder methods and so on. And that's really, I would say, something that we should praise, because in software, it's easy for you to introduce complexity in order to address requirements, but it's really difficult to deliver, I would say, simple solutions without disrupting existing models, right? And but at the same time, if you can address requirements, that's definitely the best implementation of it, and this implementation achieved it. Okay, so virtual threads, they will actually employ a small set of the so-called platform threads, used as carrier threads. So carrier because at the end of the day, those threads, they will carry the virtual threads on top of it. And behind the scenes, they mapped again to the OS kernel threads. Okay, there are some new methods, and some specifics here in terms of modifications and considerations regarding the thread name and how it is set and priorities. In comparison to the usual Java lang thread, in case of virtual threads, you cannot change thread priorities and so on. But I want actually just to, this is a glimpse of the API. Okay, by the way, I think I will distribute this presentation after my talk, so feel free to get a hold of it. But I want to shift gears now and actually go to my code and present you the first demo. Also, once again, you can see we have the OS thread and the platform thread, and on top of this, these several VTs here. These are the virtual threads. Okay, so let's do that now. Oh, I am facing an issue with my hardware. Just one sec, please. Okay, cool. All right, so yes, I'm using Eclipse. I have this application here, no tricks here, just one class, a utility class for the database connection, okay? But I have two implementations of a simple application that will actually run a query. You can see it's even hard-coded here, so nothing complicated, okay? But the first one, I call it Platform Threads Oracle JDBC, okay? And the second one, oh my God. Let me just fix that again. Okay, and so you can see the first one is called Platform Threads Oracle JDBC. You know, you can see 1,500 queries here. And this one, I use the classic platform thread, okay? So I'm using the new thread constructor here. The other example, actually, it's pretty much the same code, but instead of using a platform thread, I execute it with virtual threads, okay? So let's do it. In order to perform our comparison, you know, my OS is Windows, so I'm going to Task Manager and inspecting the number of threads here. You can see 3,753. Okay, so let's execute the first example that I have first with platform threads. Okay, and see how that works to execute those queries, right? So yeah, I'm gonna run it from the command line because there's a little bit of a ramp up, you know, phase that happens inside the clips that takes a while, and I want to present as many demos as I can. Okay, so that is actually executing. So yes, you can see that I will start to execute and run my queries and then equal the results. Okay, so nothing too specific here, but when I go to Task Manager, I can see that there's a sharp increase in terms of the number of threads that are being used now. And I mean platform threads mapped to OS kernel threads, right? It jumped from 3,700, if I'm not wrong, to 5,300. Okay, so you can see that actually there's a spike, you know, this sharp increase. Okay, so I don't need even to wait for my code to finish executing all the queries, okay, because when I instantiated the queries, actually that one-to-one mapping already happened. So I can just close that. Okay, you can see that actually the number of threads, you know, came back to 3,700 threads. Okay, so we'll do the same thing with virtual threads now. So let's do it. Okay, so yeah, it's just a matter of you know, running the other class now with virtual threads. Okay, so it will start to execute. Oh, what's happening here? No, that's it. Okay, cool. Yes, but now if I go to Task Manager, you can see that there's no spike here. Okay, so it's quite stable. At the end of the day, it means that if you are using and adopting virtual threads, you are using less resources. Okay, so it means you know, making a better use of your processor, memory, disk, you know, and possibly network bandwidth, and you know, everything else. At the end of the day, if you are using, if you can reduce resource utilization, you are, if you are deploying, you know, and you have an application that handles a massive amount of requests, a cloud application, a backend, and so on, right? If you are using less resources, you are saving money, right? So that's really interesting. And the example here, you know, the difference is really simple, okay? It's still stable at 3,700, but you may imagine what would happen if we are talking about a cloud application with thousands of requests and so on. This is just my laptop running on Windows, okay? But you can clearly see the difference, okay? So that's the first comment about using JDBC with virtual threads in my first demo, okay? But let's proceed now. In terms of the synchronous and asynchronous models, you know, like fire and forget, and you know, in the entire request and response that is actually blocking. You can see with synchronous JDBC now, we can combine virtual threads with the JDBC driver and still perform a blocking calls, but in a kind of optimized way, you know. But again, you can still use, of course, reactive streams with our JDBC driver. Okay, we are talking about non-blocking as well. If that's an option, I don't know. Perhaps you are using Flux, or you are using any other framework, RX, Java for other layers, but you are not doing that at the you know, database or data layer or integration layer. It might make sense for you to also extend the implementation in order to have, you know, reactive streams from end to end. Okay, and that's covered as well. The first one I want to present here is called RSIDEN, Reactive Streams Ingestion Library. Okay, is the one. This is the one that actually implements what I talked about, the direct path insert. Okay, so at the end of the day, it uses a proprietary mechanism of the Oracle database. Okay, that's not the case with our JDBC, the next one. Okay, but for this one here, in case you happen to have an Oracle database as your database for your project or your system, okay, you might want to have a look at this one if you are using Java and JDBC. And with direct path insert, okay, as I said, it will bypass SQL and write directly to the DB files, using an internal proprietary format, and it's really quite performant. Okay, so I have sample applications here. By the way, I have 2 examples, just a quick intro to show you the API and how it works. Okay, and the model, it's pretty much the same publish-subscribe model that we are used to. But you can be creative and you can see how complex the architecture can be. And then I have a second example with messaging and AMQP, MQTT, and Stump as well. Okay, so let's proceed to have a look at these couple of sample codes as well. All right, I can close these ones here now. The first one I want to show you is the, where is it? RSI introduction. Okay, the API is quite simple. Okay, as I said, we have publishers and subscribers. Perhaps a simple publisher is a good one. By the way, I have many blog posts that cover pretty much everything that I'm talking about here. Okay, so you can, the explanation is there, including GitHub and all the sample code. You can have a look later if you want to further explore it. Same thing with RSI, with JDBC, and even the entire application and architecture for the example with messaging. All right. With RSI, then it's simple. First thing you can see just a few. We have the publisher here. The main component is called Reactive Streams Ingestion. I instantiate it and I provide the connection information, JDBC URL, user, password, the target schema. Additional configurations can be performed. A worker thread is also can also be used. As you can see, I'm instantiated it here. But for this one, I'm still using platform threads. Okay, because that's not the focus of it. But my example with messaging, I'm actually using virtual threads as well. Okay, and then I just create this publisher. Okay, and I actually link it to my subscriber by using the RSI component, and then I can publish. I can batch and publish. The records, and that's it. It's the old publish subscribe model, or if you prefer the gang of 4 patterns, observable and observable, but it's pretty much the same thing. With this one here, first I can show you I have this customers table. It's an empty one. Okay, so I can just come here and execute this one quickly here. You will see that it will run, and then insert the components. For me, it's quite, there's a little bit of a ramp up, but okay, it's executed now. If I go there and then I run the query, you can see that my records are inserted here. Okay, I'm just talking about 6 records here, but we'll have an example with 50 and messaging as well, so you'll see how performant that is. Okay, and that's actually then my second example. Of course, there are other options here in terms of the publishers that you can use, even a third-party full publisher that you get out of the box from the JDK and so on. Okay, but the second example is actually now RSI example. This one here. Okay, it's oh, sorry, here. So you can see I have the, oh, by the way, let me just present the architecture. So that's the architecture. I have a topic producers, okay? I'm using ActiveMQ as my message-oriented middleware mon, okay? And the producer, it can be JMeter or any other tool. By the way, I created a message producer with virtual threads because I'm talking about virtual threads as well. The protocols you can see then here, AMQP, MQTT, Stump, and so on. And I have several different listeners, okay, that will actually, I will start, and they will listen, receive the messages, and then perform the ingestion and store that in our Oracle database, okay? Oh, I'm facing that issue again. My apologies. Okay. Yes. Okay, so that's the architecture of it, okay? I have the listener for AMQP, MQTT, and Stump here. And I have the message producer, just a simple retailer table that is actually the one that maps as a kind of ORM to my database table. Okay, so let me show you that. By the way, I forgot to show it, but the RSI API is quite simple. It has just some simple annotations that you can use. So you can see a string entity here. It's like, you know, a ORM like Hibernate. I just map it to my database table, and that's it. Okay. In terms of the listeners, I can show you as an example the listener for AMQP. Okay. I'm talking about JMS. So I have the usual imports for JMS here as well, the connection factory and so on, right? And I connect it to my ActiveMQ message-oriented middleware, and I start the listener. It will be listening. I can generate the messages and then ingest everything, okay? For this one, I have then a second database table. You will see that it is empty at the moment, okay? So I will execute it. Let me do it. Let me start. Yes, let's start with the AMQP listener here. But before I do that, I forgot I have to install my message-oriented middleware because that's the component that acts as the mon for me, okay, for this architecture. So let's do it. Starting a ActiveMQ, okay, it's a quick start. Okay, we are ready to run this one here. So I can actually start my listener now. Perhaps I can start at second prompt. Let me do it. Just a quick one. The listener will be up and running, connected to server, waiting for messages. And then I can just come to my message producer here. And you can see the producer. I'm using virtual threads again. I just start 50 virtual threads, and then I send 50 messages. Okay, I have hard-coded, you know, JSON file here just to resemble one public data set that we kind of reused for this code sample here in the demo. Okay, so if I do it here now, I can just run this message producer. Okay, it's a quick run again. Sorry. And you can see, okay, it's done. So I come here and I just list, and you can see that I ingested 50 records instantly. Okay, so this is just an example, but you know, in real world scenarios and applications, you can imagine what you can achieve in order of having better throughput and also data processing for the solutions and your requirements, okay, when you deploy that at scale, right? Because again, I'm just using my development environment here, and that's a local one, my laptop. All right. So yes, the last one that I want to present is actually R2DBC, Reactive Relational Database Connectivity. We have many vendors implementing this reactive strings implementation, okay, including Oracle. We have this Oracle R2DBC driver. It's open source. The link is here for you as well. If you want to have a look on LinkedIn, please do. Okay, by the way, beyond my blog post. So the documentation is here, you know, plenty of examples and everything for you. And with R2DBC, the nice thing, again, is that I can use this library along with JDBC driver and virtual threads as well. And the reactive strings libraries, once again, you can see here RxJava, Akka, reactive strings, and so on, right? And for this one, I also have an demo. You can see the code here. When you convert from blocking code to using R2DBC, basically, I have here the usual, you know, statement or prepare the statement. I execute a query, I get a result set, I process the result set, and that's it. Okay. With this second one, you can see an example with Project Reactor here. I have the Flux component. You know, I have the Fluent interface with all the operators that we have in reactive strings libraries. Okay, I can process it, and that's it. Okay, it's also another interesting way of using it. And I happen to have one last example here with R2DBC as well. It's actually just a simple one. I just read some files from the pretty much the same database. Yeah, and this is the source code. You can see I'm using mono here. Okay, mono front, and then I just pass an existing connection. I create the statement with my query. I execute, and then I apply the operators, and that's it. I can also use Flux, as you can see here, including the references to Project Reactor. Okay, I can then just execute this one here. No tweaks here. It just actually retrieves the IDs from the same table in the database, and that's it. Okay. So at the end of the day, when we speak using virtual threads or reactive, Oracle JDBC and Oracle, we support both. Okay. If you want virtual threads, you can combine the JDBC driver with virtual threads, and revert to using blocking coding, and perhaps that's easier to debug. If you want to use reactive, we also cover that. We have R2DBC, we have RSI, and we have the reactive extensions. Okay. In terms of having this final comparison here, the benefits of virtual threads: easier to read and write, easier to debug. As I said, all the tools, they use the classic, threading model that we have in Java, integration with all the tools. Then, by the way, again, it doesn't alter the basic concurrency model of Java. It's available from JDK 21. Limitations of virtual threads: I would say some libraries and frameworks, they are still not compatible, but the situation is really changing, and actually it gained traction, and we have now pretty much all the main frameworks implementing it, including Spring and so on. Okay. Benefits of reactive strings: many reactive libraries, a string-like API with functional style, low-level concurrency is handled for you. But at the end of the day, when we abstract and we hide that complexity, it's a little bit difficult for you to also debug. If you are doing reactive programming, you know what I'm talking about. There's a little bit of, I don't know, but perhaps some people say that it's difficult to learn reactive, a steep learning curve, and it is, again, harder to read, write, and debug. Right? Last thing I want to talk about the latest release of our database, Oracle Database 23 AI, over 300 major new features. It's impossible for me to talk about that, with the time that I have this evening here. But it has a major focus on AI for data features, developer related features as well, and the usual mission critical features, several improvements. Okay, the one that I want to highlight is AI vector search. Okay, so we have a new data type, vector. Okay, and on top of that, several extensions to SQL, like some specialized functions that can do all the low-level math for you in terms of implementing embeddings and doing semantic search as we do in Gen AI and so on. And that's a great thing. You don't have to reinvent the wheel and start from scratch. Well, all right. Even if you are using a specialized library, it's interesting perhaps to combine and use these features. Okay. Other things related to this database version, JSON relational duality views. So you can combine the best of both worlds, relational, but also object-oriented programming with JSON, True Cache, which is also a quite powerful cache implementation that is available out of the box. With GraalVM, we are also now implementing JavaScript stored procedures in addition to Java and other options, and the mission critical related features. All right. If you are interested, by the way, this database, you can try it today. It's just a matter of scanning this QR code. There's a virtual box version of it that's free. You can also get a container image. By the way, my examples, I'm running locally a container image. Okay, so that's really quite straightforward to use. Okay, and I do recommend you to have a look. And if you are doing Gen AI and learning about vector search and semantic search and similarity search and so on, that might be a good option for you. All right. All the technical references are here, including my blog posts, as I talked about. Okay, our documentation as well. So once again, I advise you to have a look. Okay, I'm a developer evangelist, so I'm basically a community guy. So feel free to approach me on social media as well. You can see my Twitter handle here. It's easy. You can easily find me on on LinkedIn, and if you scan this QR code, you get all my social media channels. Okay, and I will be happy actually to collaborate with you. Last thing here. We also have Oracle Live Labs, many free workshops offered by Oracle, not only about Java. We have Python, we have Golang, we have DevOps, we have databases, cloud. Everything is there for you. And again, free workshops. Okay, so just go and visit Live Labs and have a look. We have this program, Oracle ACE, as well for distinguished community members. You can see 3 different tiers here in terms of how far you can go, right from associate to director. If you think you have meaningful contributions, in terms of working with Oracle-related technologies or open source or Java, feel free to approach me as well. and perhaps we can have a conversation, and I will understand how far you are, and I'm more than happy to nominate you. And last thing, of course, Oracle, we have the Oracle Cloud Infrastructure Generation 2, redesigned from scratch with, cutting edge technologies, good network, and SSD disks, and even possibly you've heard about partnerships with OpenAI and Microsoft and Google Cloud, so all those main players, they are now working with the Oracle Cloud Infrastructure because our cloud has been actually, as I said, re-architected from scratch. Okay, and you can also get a free account with some always free, like lifelong services that you can use. All right. And that's it. That's my presentation. I'm gonna stop sharing now, and then we can have a look at the chat and see if there are some questions. If so, I can take those questions and try to answer them. Thank you very much.
Thank you very much, Juarez. So that's such interesting and informative talk. So we have time for a few questions from our audience. Let's see what we have in the chat. First question, I think you covered it in your presentation, but let's see, maybe you can add something. Does virtual threads kill reactive programming? Perhaps there are use cases where you would recommend using virtual threads over a reactive approach and vice versa.
Well, that's an interesting question because, in software, there is no silver bullet, right? So first you have to look, if we are talking about, a new application that you are implementing, a fresh new one from scratch, or if you are actually inheriting legacy code that you have to refactor and so on. Okay, but at the end of the day, if there's an opportunity to use virtual threads, I would say that I recommend it personally. Okay, that's not a recommendation coming from Oracle specifically. That's my opinion. But there are some cases, when you have synchronized code and to avoid thread pinning and so on, that you really have to understand. So as I said, it's not a silver bullet, but in case you are just using platform threads the usual way without complications or the use of the synchronized keyword and so on, I think that might be a good option for you. So I again, go and have a look at it.
Okay, thank you for your answer. Let's see, next question. What is about synchronized blocks causing virtual thread blocking along with the platform thread? Will it be solved in the future?
Wow, that's I would say a tricky question, and actually I just talked about this one. I answered this question because this is quite specific. You have to look at this scenario and understand your code. Okay, so there's no recipe that would cover everything. But hopefully yes. But at the moment, at the end of the day, it's your job as a developer to analyze your code and understand if you can perhaps refactor your code to use virtual threads or not. And of course, you have to pay attention to synchronized code.
Okay, thank you so much again for your presentation and answers. That's the end of our Q&A session. Juarez, thank you for your valuable input to our meetup.
You're very welcome. Thanks for having me.
As we finish, I'd like to thank you both, Yaroslav and Juarez, for their excellent presentation. Your knowledge and experience have made our understanding of documentation and Java development better. So to our audience, thank you for joining and asking great questions. We hope you found this meetup useful and inspiring. Watch out for news about our next events. Until then, keep coding and learning about Java. Thank you all, and have a nice evening.
Likewise. Thank you very much. Bye-bye.
Bye.